Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of binomial distributed random variable. And this is the previous examination question. The example is the mean of binomial distribution is 3 and variance is 9 by 4. Find the value of n, probability of x greater than or equal to 7 and p of 1 less than or equal to x less than 6. So given that the random variable x is binomial distributed random variable and given that the mean value is 3 and the variance is 9 by 4. So we know that the mean value of the binomial distributed random variable is np. So that is np is equal to 3 and the variance of the binomial distributed random variable is npq. So which is 9 by 4. So now here npq is equal to 9 by 4. So now q is equal to 9 by 4 divided by np, but np is equal to 3. So therefore q is equal to 0.75. We know that p plus q is equal to 1, p is equal to 1 minus q, and substitute q value into here, p is equal to 0.25. And substitute p value and q value into here in this expression, npq is equal to 9 by 4. We get n is equal to n is equal to 9 by 4 divided by pq. P is 0.75, q is 0.25. We get n is equal to 12. Therefore, n is equal to 12, q is equal to 0.75 and p is equal to q is equal to 0.75, p is equal to 0.25. And that is the first bit solution. And the second bit, determine p of x greater than or equal to 7. So p of x greater than or equal to 7 means 7 to infinity. So it is not possible to determine probability value x greater than or equal to 7. So we can determine using property of the probability density function p of x greater than or equal to x is equal to 1 minus p of x less than 7. So first determine p of x less than 7. Substitute that value into here. We get p of x greater than or equal to 7. So p of x greater than or equal to 7 is equal to 1 minus p of x less than 7 means p of x is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4 plus p of x is equal to 5 plus p of x is equal to 6. So we know that the binomial distributed random variable expression is probability of x is equal to x is ncx into p power x into q power n minus x. So now here n is equal to 12, p is equal to 0.25, q is equal to 0.75. So using this expression, find out probability of x is equal to 0 to probability of x is equal to 6 value. First determine probability of x is equal to 0 using ncx into p power x into q power n minus x expression. P of 0 is 12c0 0.25 whole to the power of 0 into 0.75 whole to the power of 12 minus 0. So 12c0 is 1, 0.25 whole to the power of 0 is 1, 0.75 whole to the power of 12. So 0.75 whole to the power of 12 is 0.03. Next find out p of x is equal to 1. Now here small x is equal to 1. So p of 1 is 12c1 into 0.25 whole to the power of 1 into 0.75 whole to the power of 12 minus 1 is 11. And 12c1 is 12 into 0.25 into 0.75 whole to the power of 11. So simplifying this RHS term we get and its value is 0.127. Next determine p of x is equal to 2. So p of 2 is 12c2 into 0.25 whole square 0.75 whole to the power of 12 minus 2 is 10. So 12c2 is using ncx expression 12 factorial by 2 factorial into 12 minus 2 factorial. 12 minus 2 factorial is 10 factorial. So now here in the numerator term 12 factorial is written as 12 into 11 into 10 factorial, and numerator and denominator 10 factorial is cancelled, and the remaining term is 2 6. 6 into 11 66. 11 6 are 66. 66 into 0.25 whole square 0.75 whole to the power of 10, and simplifying this term we get, and its value is 0.2323. Next to determine p of x is equal to 3 and its value is 0.2581. So similarly we can determine p of x is equal to 4 and its value is 0.1936, and p of x is equal to 5 and its value is 0.1032, and p of x is equal to 6 and its value is 0.0402, and substitute all these probability values into p of x greater than or equal to 7 expression. So p of x greater than or equal to 7 is equal 1 minus p of x is equal to 0 to 1 minus of p of x is equal to 0 to p of x is equal to 6, and substitute all those values into here. We get p of x greater than or equal to 7 is 0.0159. This is the second bit solution. And third bit solution, determine the probability of 1 less than or equal to x less than 6. So 1 less than or equal to x less than 6 means the probability value is p of x is equal to 1 to p of x is equal to 5. P of x is equal to 1 to p of x is equal to 5. P of x is equal to 1 to P of x is equal to 5 probabilities already calculated. Substitute all those probabilities into here. We get P of 1 less than or equal to x less than 6 is 0. P of x is equal to 1 probability is 0.127. P of x is equal to 2 probability is 0.232. P of x is equal to 3 probability is 0.258. P of x is equal to 4 probability is 0.193. P of x is equal to 5 probability is 0.103. So all these values already calculated here. Okay. P of x is equal to 1 to P of x is equal to 2, P of x is equal to 3, P of x is equal to 4, P of x is equal to 5 probabilities calculated, and substitute that values into in this expression. We get the probability of 1 less than or equal to x less than 6 value is 0.913.